Okay, we are live on YouTube. Okay, so today I'm going to go over an exercise I developed my own. So download that one.zip file, extract everything from it, and then you will see some material, including a R code called salary.r, simple R. Salary.text, salary.data, that's a data file. What is salary.text? Oh, that's just a different format. And also a PowerPoint to accompany it. And let's open a salary.r with RStudio. And you please try to work through this with me. So that way I can also pause and give you time to make sure we're on the same page. So do we have we all open download the file and be able to open the R code? You may have to install RStudio.
Yeah. Okay. Thank you.
Excellent. And I see Monica has opened.
I opened it, but it can't.
That's fine, yeah. So the directory has to be reset into your own file. One.zip.
Salary.r.
Yeah, salary.r. So the you can check the directory of the salary.r code under the data. The data look like we are going to read the data called salary.date. And we go back to the download file, we will see there the salary.date is here and R code here. So they are in the same directory. So if I set my working directory to salary.r, I should be able to read that data. Okay, so I go back to my RStudio, and then where should I go?
Session directory. Set directory.
To
Directory.
okay, right. So in fact, you can look at the bottom and say downloads one.r. If you know for sure that's a directory you always go to, you can copy paste that to the front of the code. Put there. So that way, every time you run it, it's going to set automatically to this directory. If you know for sure you are going to do this in that directory. Okay, for time being, I'm going to leave it also there. Okay, then try to read that data into a data frame. So everything, the spreadsheet in R is called data frame. Okay, so how do I run this? Highlight those and click run the current line or selection. Right, at the bottom is you see it has been run, and then I can look on the right to see whether it is there or not. In fact, it is there. Right. So you click on this one, you can see. Well, this is the salary data. It had a case number, ID number, gender, degree, year of degree, field, starting year, current year, rank, administrative or not, salary.
I'm sorry, I'm confused because I can't get to my directory. I found it in my downloads folder, and I set working directory to that. It's not.
Have you extracted? I do not see you extracted.
I extracted something. I have my files here.
It's an exercise.
It's
supposed to be.
I don't think this is inside of it. You have not extracted. This is extracted. So you want to reset your working directory. You set the working directory and you are one branches two. Yeah, now you should be able to
New file. New R file.
now you see. So you just
How many statistical lines in the tab we have data? I feel like if you finish ADX, then you're probably because everybody's data. Like the two quizzes, and that's not. Oh, sorry.
Yeah,
That's
I like I found a website that had all the answers which helped us do it like step by step. Yeah, that helps a lot. Yeah.
I really opened everything.
Right. You just need to type one. In the previous one, you just need
After I run this though. This.
Have you set your work correct?
Yeah.
Okay.
So there's
No, those files are not wrong. You have a typo.
Oh no, I was typing.
Yeah, you have a typo and nothing. Nothing in the wrong. No, in something you have a typo, there's nothing missing. When you see the plus sign, that means nothing. Okay, excellent. Yeah.
Oh, okay.
You want to see a graphic? Yeah, you see the graphic. Yes, you have the file. Okay, don't try to run everything, run it line by line, that way you know what's going on. If you run it 100 lines of code, you are not going to see what's going on. You have to download the art. Download the first. Okay, so the example basically is similar to this. If you can do this, you can finish the exam. In the exam, I give you data, you download data, analyze the data, and then answer the data question. So you need to really know. Okay, very good. So you see the data. All right, then we can move down a few lines to. And we can look at the first few lines using the command called HEAD head. Once you do that, you can see it's just show up the first 6 lines of the first 6 rows of the spreadsheet called data frame in R. But that's the largest one I. Yeah. Okay, yeah. So it's the same thing when I open it up using the GUI interface. And in fact, you probably can also run the opposite. Let's do tail. Yeah, that will be the last 6 lines of the code. You have head and tail. And so this is apparently some kind of a salary data from a school system. So, all right. So there's also another command called strr, basically called structure. Look at the structure of the salary data. If you want to find out what those function does, type question mark structure. Oh, sorry, no, I did something wrong. Question mark structure, and then run those lines. You will see the help page on the right. Right. So that's the base function structure. Oh no. I shouldn't put a parenthesis there. Just put a structure. Right. Right. So yeah, structure. Put the object there. That's the usage. What this function does is just compactly display the internal structure of an R object. That's some very detailed explanation. And hopefully some example. Yeah, in the example here at the bottom tells give you some example how this function can be used. If a structure 1 to 12, and you can actually run this structure 1 to 12. It basically shows what it is. So okay, so and in everything start with the pound sign is a comment in R. So that's just the explanation. It's not being executed when you run R code. So very often we use comment to help other people and ourselves and or tomorrow's ourselves to understand what we are doing today. In fact, this code is probably written in 2010 when I've just come to Spelman. So this code has been written a long, long time ago.
Did you already run the structure of the salary?
Yes, I did. So
is that it?
yeah.
Okay.
So that's what the structure of salary basically shows. There are 11 variables. Each variable is a column. And there are like 20,000 observations. That means 20,000 rows. There are 11 columns. It's case, ID, gender, degree. It's basically a spreadsheet. Right? If you go back to the spreadsheet, you see that each variable is basically also called columns. That's basically this SAL data there. So there are 11 columns in this data frame. And how do we pick individual columns? This basically called, if you recall from edX course, this is how you access individual data. That's basically the edX. So this, we can put a column that's the gender. The gender is male or female. And we can look at the column. And you can, this part you can run it. Right, so this will be the line 25, that will be row from the second row to the fourth row. And this will be the second row and third column. That's the value there. Right. So, and this will be the 10th row to the 15th row and second column, third column, and fourth column. In fact, I can do this. I can do anything I want. As long as it's inside of the data, I can do, say, 5, 1, and 99. That's the rows. I can do columns. I can do the last column first column, second column, and first column. I can do, as long as it's valid, it can be shown. In fact, this is how the data can be reorganized. Right? If you don't like the data present, you can reorganize the table if you want to present to someone else. So if you work in a company, you want to generate a report, you can. That's why you can reorganize the table. So, well, here's a example. How we have all the data there. How this data? We can use a table command for to do some tabulation. Okay, first, how do I know TABLE does? If you want to know. Yes, excellent. Let's run question mark table. And on the right-hand side, actually, this is something called cross-tabulation and the table creation. And table is also part of the basic function in R. It's by default, it is there. So this is there are also examples at the bottom. But if I say tables, salary, gender, what does that do? It actually basically tabulate the gender data in the gender column. So there are about 4,000 female and 15,000 male in this data set. That's what the table does. Okay, and then I can generate do some simple descriptive statistic on this. I can do a histogram of the salary, see the range of those. Right, let's generate a histogram of the salary. Well, some people got a monthly salary like over $15,000. That's the highest one. But it looked like the average. If I zoom the figure, let's see. It looked like the peak is around 40,000 something. That's the distribution, the histogram. What is a histogram? Well, yeah, it is a graph or figure. But histogram is a way to present some data, see how data are distributed in some categories. Right? So if basically, like say, if you have many books at home, you want to see organize the books by their price. You put a $10 piece of books there. You put a say $20 to $30 book in a second one. Then you can compare the height of the number of books. You will notice how much money you spend on each category. I guess that's basically a histogram, right? So, I mean, that would be literally a physical histogram if you pile all those books, actually. But this is the same thing. In this case, each being will be the number of people in that category. You pile up. If we can imagine all those people pile up on top of each other, that would be how high the pile will be. So that's the histogram. Okay. Now, if I ask some question, say, how long did it take to get the job after they first get their current academic job after they get their degree? How do I do that? And basically, well, if we go back to the data, right? So we have the data, say the year they got their degree and then the starting year of their current job. So I just calculate the difference, basically the difference, right? So I just calculate that interval of that, right? But if I go look at the data again, oh no, yeah, right, that should be probably right. If I look at the data again, you will see now this spreadsheet has an extra column. It's the same thing like in Excel. If you want to manipulate two columns, generate a third column, that's basically the same thing. So I now have a third column. In fact, I call it the interval with this dollar sign. That's the third column. Interval and starting year minus the year of degree, that's the interval. So if I can also do a histogram on the interval, then I know in general, it's not there. I must have something. What did I do wrong? Margin, oh, I know, because I didn't give enough space for the figure to be generated. Okay, now it's, okay. All right, so, wow. Gee, I guess some people, probably this is not their first job. You'll be really disappointed to take 40 years to get so, but it looked like majority took like 3 or 4 years after the degree to get this job. So, but it's also interesting there are some minors inside, which means some people start working on this position before even they get the degree, right? So you do some simple analysis on the data, you start to understand some interesting things the data can tell you, right? So, okay, so let's.
Dr. Chen, were you getting an error when you ran that?
It says figure margin too large because when I run this, I put my I gave too little space for the figure to be generated. On your computer, you should have no problem. I have this problem because I put it on a screen, and the monitor set my screen to a very small size. So, and also I put my font very big so you can see it. Right? On your screen, you shouldn't have this problem. So, okay, so then, but once you have some data, why we use R? Because we can ask some question and then to analyze to answer them. So one question is say, is there a gender bias in salary? That's probably a question many people are interested in, especially at the Spelman. Right. So we can look at the plot. The way you want to see this, people say picture says 1,000 words. Right. So if we can do something called a box plot. Let's see whether it let me. Okay, good. It let me do the plot. If I put the plot bigger, you will see this. So you can Google. How do you get bigger? You see, there's a zoom. You click on the zoom, you can adjust the window to see that. So, and how do I know what the box plot does? Again, I'm going to, oops, sorry. I'm going to look for the help page of box plot. So this is something called the standard box and the whisker plot. There will be some definition, but I want to see the explanation what it does. It didn't. I guess it assumes everybody knows what it means. So let's go to if that in this case, Wikipedia probably offer a better explanation. See, it does. So box plot is a descriptive statistic, and it basically displays data by their percentile, and the actual word is called quartile. Quartile means the 25%, 75%, 50%. That's what it means, right? So, and then it also plots some outliers. So that the line in the middle, that should be either the mean or median. Let me see. Lowest data. I would think that's the mean. No, that should be median because the quartile, that must be 50%. So that would be if I, based on the Wikipedia, that should be plot. This should be 50%, that would be 75%. Wait, that shouldn't be right. 50, 75, that become, what's the outer layer? I want to know whether it's 95% or 90%. Sorry, maybe we can do more reading after class to figure out this outer line. Is that 90% or 95%? It's actually in the menu, but I guess when I quickly go through it, I didn't see quite obviously there. So it's also something you can change though. Okay. Now, but the point is, when you look at that plot, you will see the male have a higher the mean value. The 50% value seems to be higher than female. Right? But then you will say, is that we will say, is that a significant or just coincidence? Right? So the way we can answer that question is doing something called statistical test. And to do that test, we can first find out the salary and by their genders. So, but right now the salary data in one column, all the male and female are there. But how do we find out the male and female salary? But we know the gender data in a different column called gender. So we need to pick the data in the salary by the value in the gender column. Am I making sense?
What are we trying to find out?
We need to find out salary of both male and females separately. Right? But right now, all the salary are one column, all in one place. We need to find out the salary for based on the net value in gender.
Isn't the box?
The box plot, yeah, box plot already does that, but we need to find out the value. The box plot generates the figure of it, but now we need to find out the actual number of it, right? So the way I'm going to use is this double equal sign. That's a logical operation. So if I'm going to pick anything in the salary columns, this is the salary column, but the way I'm going to pick anything there, the gender is F. And then I call this FS for female salary. And I do it again for the M, when gender is M, so that will be the male salary numbers. I run these two lines. And this time we can write, you will see FM is about 3926, MS is about 16,000. And if you recall, table, cell, gender, there are 3,926 females and about 6,000 males. So now this, you can double check whether you always double check when you are running analysis. This is also an advantage of R because it's interactive. So you can double check the value. Sometimes when you're doing assignment or you see your code is running, you can look at on right, check the variable. Are those variables show the value it's supposed to show? If it's not showing, then it's something, you know where the mistake is. Right? So try to correct that mistake. So those technique, this upper right panel is the panel which shows the internally how your code are running. So you need to, if you want to figure out the mistake is, you want to pay attention to the value of those numbers, those symbols. Okay. So, and this time I'm going to calculate the mean and mean salary value for both FS and MS. Right. So this time, well, the mean of the male salary is about 48,000. The mean salary of female is about 41,000. So that seems to be, but still, I didn't show is this significant or not. It seems to be about 700 difference. I mean, is that bigger enough to? I mean, it feels like a bigger enough, but can we put something like I don't know, maybe we should call it academic rigorous thing to that concept. Okay, so this is something, one thing you can do is called t-test. This is a standard statistical test. You basically put a significance value of something. Is this, if you see a difference between two things, it could be happen just by chance, or it could be happen unlikely by chance. The t-test basically is something to show this. We see a difference between male and female salary. The t-test is going to say, well, we see a difference. The chance of that difference due to simply random will be that number. That's called p-value. If that p-value is very, very small, that means it's really unlikely the difference we see is caused by total innocence random things. Right? It might be there's some systematic issues in this one. That's basically what t-test is going to tell us. So this is basically shows the power of R. So, and this is very sophisticated test, but all we need to do in R is just t.test, and in fact you can see the help function t.test. On the right you will see this is something called student test, blah, 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 there's a lot of explanation. And the example at the bottom. In fact, there are books and book chapters on those, and you can read it to do some more reading on this. But to apply it in R, that's it. We just need this one line of code, t.test, male salary, female salary, and then we will see it. Right, so there, and we just finished a standard t-test of male and female salary. This is also something called two-sample t-test, and you need to pay attention to this p-value. What's the p-value for this? That's actually the smallest number the R t-test can do. Basically, this is an extremely small p-value. So what the p-value, very, very small p-value, basically say it's very, very unlikely. So the chance is much smaller than that for the salary, the 700 salary difference between male and female is caused by some unbiased process. There must be some biased processing in this. That's basically what this p-value telling us. Now there are some other things like a t-test often require the sample distribution look like a bell shape, but if you recall, the salary distribution is not bell shape. The one way to change the non-bell shape to a bell shape is by taking a log transformation. So if we do that, do a log transformation, we got the same thing. So this is basically shows this is a very robust difference. The difference between that is not because of some numerical issue. It's just a different. I do a log transformation. The observation is quite there. In fact, t-test is one of the most robust statistical tests. If t-test doesn't show something, if you do it many times, it's often there. Okay, and in R, there are more sophisticated method. One is called linear regression. This is a very important method. We'll use it many times in this class. In fact, if you in graduate school, they can even spend 1 or 2 semesters just on linear regression, linear models, just for this. But in R, we can just use it, and there's a lot of theory behind it, but we can just use it, right? So we can just do a linear regression between R and gender. Linear regression basically is also the same thing called a trend line. When you do an Excel plot, if you right-click on the Excel plot, you say add trend line. That's the same thing. Basically, to see the trend in the 2 things we want to study, 2 factors we want to study. So we can do a LM for linear regression. But if we just run LM, right, it generates a linear model. There's the intercept the slope. Right, the linear model is something called y equal x plus b. This will be the intercept, that's the slope. So, but we also assign it to n for model. Yeah. But in R, you can also, the linear regression in this case and the t-statistical t-test actually are really the same thing. If I do run the summary will report a lot of information here at the bottom. It actually says based on the linear model, salary over gender, coefficient, that's the slope. So this is also a positive slope. That's the intercept. The positive slope, that's basically the t-test p-value. So basically, we see a positive correlation between gender, and again, the p-value very small. So gender does influence. Basically, they say gender influences salary again. But what the difference between the linear model and t-test? You can do multiple. You can put multiple numbers into the linear model. That way, you can do more sophisticated analysis. In fact, right, so actually, you can do different ways. There's also another variable here, something called the R squared value. That's a very important concept. So that means how well the linear model fits the data. So I'm going to skip that for now. But R squared is a very important concept you want to understand. I'm going to skip this. You can also manually calculate that R squared. I'm going to just skip this. Okay, so now I'm going to ask you to examine how the rank going to affect the salary. Rank basically assistant, associate, or full professor. Right. So I showed you how to study the gender on salary. How do we do the rank? I'm going to let you to study. The rank will be, right, if you go back to look at salary data, you see there's also a column called rank. And I'm asking you to, how does the rank influence the salary? So you can try to figure out a way. Let's give you, say, 5 minutes, something. You can work as a group, try to figure this one out. Yeah. So basically, if you can do this, basically this is how the exam is going to be like. I give you data and then ask you a question. So something, there'll be, say, several columns. Say there's a traffic pattern, there's a time. How does the time influence the traffic pattern? You need to do something like that. Right? It's basically the same thing. Yeah. So the rank, right, assistant, associate, full professor. How do you see there's some association between salary and the rank? This should be obvious. Otherwise, why would people try to be a full professor? So, but you want to do this quantitative, right?
maybe salary versus column row of X, Y. So whatever you want. Yeah. Oh. So whatever got you. Yeah. Yeah, so we can do this. Well, we're trying to figure out. So I was just how Histogram. Is the guy I tried to do it's not working. I put it in as an art source. There's always a question.
So you would do salary.
So the extra be about no. I feel like I'm very
Okay, now change the working directory to that.
Oh, I see what you said.
I just changed the source from the source file and the data. That looks like the file.
I don't even know if this
Yeah, so this is, you want that to switch, like you want it to be.
Oh, that's one. So then you can run the read table.
So how did you do that? You open this in R.
Right.
I think this was.
I just thought we
That's
directory might
Okay, if I.
Right.
When do you turn in but yeah, so my question is, how do you if that's anytime, like you've done it once.
Right. Each person has to read it. Okay. You are not highlighting that. Now you read the file to AM, but if you run later, then now you do. And you click edit.
Okay. Thank you, sir.
Okay, you need to know how to work on this all by your own, because that's what the exam will be like. Very good, that's a plot. But can you assign a p-value to it?
Oh.
Very good, you show a plot, you can see the full professor certainly have a much higher salary than the associate. And associate seem to have higher salary. Yeah, that's a very nice picture, says that's how it works, right?
Oh,
very good, but can you assign some p-value to it?
We did a video summary of
Very good.
That's, I mean, that's.
That's gender.
Right. So maybe
different. Very good. Yeah, you just have to model the gender. My analysis on gender just apply it to rank. Very good. That's a good way to go.
It should either, if it's
still
but I don't know how to find it when I go back. I can't find it.
Extract files.
It says that download slash one. Yeah, so I usually save it.
Was quiz 3 due today?
Where is quiz 3?
I haven't done quiz 3. Was it due today? Oh, it's Monday.
No.
So I'm over in this now. So once you're in R, when you're in R, so the way I see it is you go, so you open your record.
Well, yeah, but you can open it. I don't think there's enough space on this computer for our computer.
No, there's no. You just have to put
Okay. Well, Saturday, basically what we're doing right now is that this is what yeah, and this is an exercise. One, nothing MSC and our corporation. That was the.
No, that's the Mac people. Because I use Mac.
Oh, so these are one.
Right.
These are all, yeah.
Well, to find people, I'm
Salary hard.
going to find like.
So now you're
Okay, who has found out the p-value for this?
Oh, this was just a variable.
Very good. Yeah, that's someone has done it. Very good. So all you need to do, in fact, just replace gender with rank. It should be working. So at the bottom, if I use one line to do this, I just type salary and linear model, and this is salary over. As this line of code should be just do this work. Right. So it's actually highly significant positive one. So you can see the p-value over here at the bottom. Yeah. So if you just use one line of code, that's the one line of code. We can also do a box plot to see this. Salary. That's the right. So you can also use a box plot to see this presented. But this is actually often the case. You need the actual number to understand it. But when you present it to other people, you also have to present it a figure. That's often the people doing analysis. So we actually need the number to quantify things. But when we explain it to other people, we often need a figure. That's basically the job for many of the data analysts doing. So we love the number, but in the end, we need to present the number in a figure to other people to understand. So okay. So I'm going to remove that because
So I mean, I did the t-test and I keep changing the answers, but like I wanted to see that we had all these things.
Oh, excellent. So you are doing this, yeah. So you are doing the salary for social. Oh, I see. Okay.
But like when I try to find the list, it says
So you have to remove the not available. There may be so you can look at IC. So when you do calculation, sometimes if the data have not available, you need to do this. You need to do mean, say x, and then remove dot NA dot remove equal to. You have to remove that. Otherwise, the not available will be considered part of it. So if one of your data have an NA, at least NA which is not available, you want to remove that from your analysis, and you put NA dot remove equal T for true, and then the calculation won't consider those NAs. If you don't do that, you will get the mean value basically of NA. So if you want to remove that,
Okay. Don't erase it. It says NA.RM.
yeah, NA dot RM. RM for remove.
X, NA.
Right, X can be anything you are analyzing, right? This is not literal. Actually, just something I put it here. In your case, if you analyze gender, salary, this will be the things you are analyzing now. So. And the data also show rank is much better a predictor of salary than gender. So maybe there's a association between gender, basically because there are more male faculty to be full professor, right? So maybe that's the case. So in fact, we can even do a tabulation here, right? You see, for male and females, male full professor is 8,000, assistant is just 25. So here they are just more male full professor, but female. You see, the female actually assistant associate are quite a lot. The full professor actually goes down. So basically, the trend is just reversed for male and female. Female faculty are less likely to become full professor, unfortunately. And you can actually, but this is just what we say. We can also assign a p-value to this kind of observation, and this can be done by something called a chi-square test. But before I can do this analysis, I need to assign this one to some variable. I call it a TB, again short for table. So after I do the assignment, this is something called Pearson chi-square test. Basically, I want to see whether this table has some bias to it, whether the male and female, the difference I see is significant or not. It also due to chance or not. And this also has a very small p-value. Basically, the things say the chance for male and female assistant associate for them to become full professor is significantly different. That's basically the p-value says. P-value basically this observation caused by totally random, the chance. That's what the p-value means. And that p-value again is extremely small. So I'm going to skip this. That's how I calculate chi-square manually. Okay. I'm going to skip that. I'm going to show you. So now we know both gender and rank influence salary, but how do we compare the two at the same time? Basically, if I want to study gender, people may argue, well, that's because the rank is influence salary, so gender really doesn't. But how do I convince people? Even if I remove the influence of rank on the salary, I can still show that the gender still have an effect on salary or not. So if you let's say some people wear a coat in the summer. They say, I feel warm, but people say that's because you wear a coat. And the person said, that's because temperature is high. How do we, right? So if you have two factors, you want to remove one. Then the person say, well, if you remove your coat, you still feel warm. That's because of weather, right? So here basically the same thing. And we are arguing that the gender has the influence on salary, and the rank also has the influence on salary. So if we remove the effect of a rank, then we can look at the gender effect alone, right? So basically, if we do that, this is basically what's called a multiple regression. We put this two factor into the regression at the same time, and then we do this, right? So if we do this again,
You just ran it?
yeah, I just run the code. So that's basically the beauty of R. So it's actually very complicated, the numerical calculation behind, but all you need to do, you just run the R code, right? As long as you know how to run it. But the key thing is you want to understand the concept principle and try to explain it, right? So just running is not a big deal, right? So, but if you can explain it and present it, that's actually make a huge difference. Everybody can drive a car, but not many people can sell a car, I guess. Yeah. So that's a difference. Okay. Well, if we do this, you can see the apparently the rank indeed has a quite significant effect. But even when those effects are considered, the gender still have a 0.046 chance to influence the salary. So it's still significant to some degree. So this is actually of concern, right? So we know a lot, the rank affects salary, but even when the rank effect is removed, this is actually interesting. We put all the factors there, but when the rank is there, its effect on salary will be considered by the linear model. But then the gender effect on salary will be separate. You see, do you understand it? Okay, so we have to remove the influence of rank on salary in order to consider gender. But the way to do is to put the two factors in the regression at the same time. Because when we do this, the influence of a rank on salary will be put on the rank itself and not be put on the gender anymore. If we do this alone, the effect of a rank will also be put into gender. If we use gender alone, so that's a difference, right? So if we want to consider the two factors separately, that two factors have to be put explicitly into the model itself. Yes.
Can you explain again how we read the resulting, like how we read the result?
At the bottom.
Yeah, but like what is this telling?
Percentage. That's basically p-value. Sorry. Okay. Thank you. Yeah. Sorry. This PR means probability. In fact, that's how the p-value is defined. So the p-value is basically you calculate a number and the distribution is greater than that threshold. That's basically the p-value here.
What's the threshold again?
Threshold is here.
Oh, okay.
That's the t-value. So the probability greater than the t.
Oh,
that's the p-value. Yeah. Thank you. That's sorry, I didn't explain that. Thank you for pointing that out. So those are something called the t statistic based on the definition here. So and this is basically PR means probability greater than this value on the left. Those are the p-value here. So this is 0.046 for the.
You know how significant
how association is caused by random.
Okay.
Right, and if this number is very, very small, that means the chance caused by random chance is very, very small. Yeah. So if you want to prove your theory, you want that number to be very small.
Okay.
Right. And so any theory you want to prove is always the alternative hypothesis. So any theory, the whole world without your own view is always a random process, or the null hypothesis. That's the difference. So if any thesis or proposal you written must be alternative. So that's actually by definition. So, but the whole world without your theory or your view or your proposed study is always the random process. So, yeah. Or technically, they call null hypothesis, N-U-L-L, the null hypothesis. Basically, the whole world without you. So, yeah. Yes.
In the results, why does it only show the associated and full and not consistent?
Essentially, because when you compare something, you have to compare it with something. You have three hypotheses that are hypotheses. Basically, the basic exposure
And what's the difference between the second one and the top one?
Which, what do you mean second one?
134 and 135.
Oh, 135, I'm looking at the gender all by itself. Right, but if I run the linear regression with only gender, that means the effect of rank is actually also put into gender. Basically, I'm putting everything all together into gender. So the 135 is inappropriate because I didn't consider the effect of rank. But in reality, rank has a much influence on salary and gender.
When I try to run that one, it has an error.
Yeah. So, that's the last line of the code. In fact, so even this is a very short analysis. I mentioned t-test. I mentioned linear regression. I mentioned the null hypothesis, alternative hypothesis. I also mentioned the chi-square test, tabulation, data subsetting, how to take a columns. That's actually quite a lot if you understand this. Yeah, and how to change the directory, how to do a plot. See this. If you can do this all by yourself, I think you are ready to go. So, yeah.
Are you gonna post this today?
This is always been posted. Oh, you mean the video?
Yeah, we're recording, right?
Yeah, I'm recording this one, so I can't stop this and post this one online. So yes, yeah.
Did you run that line? Because I can't get it to run online actually.
Which one?
I think it was 135.
135.
Yeah, I couldn't get it to run. Yeah.
Oh,
I thought chapter 1, 134.
something is not right. I run this one before. Why it's not running
I thought you
anymore?
ran it with 134.
No. This should be running. This has to be done by t-test. Sorry. Why I'm doing this? I thought this is salary. Sorry. This should be salary.
Oh, that's what
Sorry. Yeah. Why I'm running this side? Thank you. This should be salary. Yeah.
Which one?
I mistyped that. This should be salary 135. Instead of running ranking, I should change that to salary. Thank you. Well, I never noticed this typo. So yeah, that should be salary. Yeah. So that's probably something called intentionally blind on this. So I never noticed that's a different word. Somehow I always read that as salary. So yeah.
Okay, so no, my art studio wouldn't run on here, so I'm just looking at this. So I'm just saying, where should we
No,
be?
you have to.
I did on the.
No, you have to run art studio.
On the main.
You have to.
On Fosford, yeah, I did, and I ran it, and it still wouldn't come up. I did that like 8 times. Then it's gonna be better because I have it on my computer. So we're not doing.
No. Art studio is.
See Dr. Shannon, every time I open it, it said it does that. Just talk.
You probably have to put it in
Well, it doesn't matter because I have it on my computer. So that's why I was saying, are you gonna post it now so I can do it on my computer?
I know. You
Yeah, it says like.
put
That's what we just did.
you put it in a program.
It's all done.
Yeah.
Do you open up the file?
There.
Oh, I see.
Now okay, I'm going to stop